Alrighty. So I'm going to be presenting work on how we used a mobile game to explore how humans and AI can protect each other. So in our scenario, we have a payload depicted in blue, which needs to go along a path to its destination. And while it does that, it needs to avoid moving obstacles, shown here in orange. And in order to assist it in this task, there is also a defensive agent, shown in yellow, which accompanies the payload and pushes obstacles away from it. Within our game, they're shown like this. You may remember these from the joystick sensitivity talk on Wednesday. So there's been several previous solutions for defensive agents. These include a reach avoid game where the defender uses heuristics to defend or to guard a static area. A perimeter defense game where the defender's trained with imitation learning to guard another static area. And a moving payload defense scenario where the defenders guard a moving payload using reinforcement learning. And there's been several solutions for the payload agent as well, such as moving obstacle avoidance using deep reinforcement learning. However, all of these solutions are purely algorithmic. They do not include human in the loop whatsoever. So for our work, we have the human collaborate by controlling the payload or controlling the defender. So, but you might ask why we even want a human to collaborate in the first place. Well, the human and the AI can combine their strengths. For example, in an automated car task, the human and the AI can share control, with the AI optimizing for safety based on the human's behaviors. And they can also cover each other's weaknesses. Like if there's a lane closed for construction and the automation can't handle the input, the human can intervene in that case. So this is an example of human automation collaboration. And it begs the question, which roles the automation and the human should be placed in our scenario to achieve this ideal? And we answer this, or we explore this, using our mobile game Busy Beeway from our previous work. In the center, we have our payload character. And on the side is our defender. It is bound to the ring around the payload. And the flowers are sub-goals, which the payload needs to collect throughout the level. These wasps are stochastic obstacles, which the payload needs to avoid, and the defender can move away from the payload. And the switch player button allows the player to switch between the roles at will. So this is an example of role switching in our scenario. The player is controlling the character highlighted in red, which in this case is the payload. When the switch player button is clicked, the control switches to the defender, like here. And when it's clicked again, it will switch back to the payload. So for our study, we recruited 10 players from the University of Arizona. These players were compensated monetarily, and their data was collected remotely using a server. These players also played for an extended period of time. At the time of writing, the longest participation was 172 days. So the first question we need to look at is how the humans perform in each role. To examine this, we introduce a baseline fully automated team and also have conditions where the human controls the payload and controls the defender. And so we look at this with the average number of sub-goals collected, the maximum number of which can be 6. So here we have the baseline rate. You can see that the fully automated team collects about 3 sub-goals, making it roughly halfway through the level. And the human as the payload and the human as defender have fairly similar performances. They do not significantly improve upon the automated system. You can see that the humans perform better as the defender than as the payload. We believe this is because the defender role requires less active control and is also more error tolerant than the payload role. We also note from this that the human as the defender has very similar performance to the automated team. So we examine whether the payload AI being collaborated with has an effect upon performance. So for this, we introduced 2 AIs. AI 1 is a cautious AI. It is focused on avoiding the obstacles. And AI 2 is a more risky AI. It is focused on collecting the sub-goals as quickly as possible. So we have the baseline of automated teams again, this time with the cautious AI and the risky AI. And then we have the human collaborating as the defender with the cautious and risky AIs. Oops. And so we look again at the average number of sub-goals. The cautious AI, as you can see, survives much longer into the level than the risky AI does. And when we look at the human's performance, it's extremely similar to the AI they're collaborating with. So this implies that the payload AI drives the performance of the entire system. So far, the humans have been locked either into the payload or defender roles. But how does this change if we allow them to switch between the defender and payload roles at will using the switch player button? So again, we have the full AI teams with the risky and cautious AI as our baselines, and then the humans collaborating with the cautious AI and the risky AI, but being able to take over each role. So here we have the baselines, once again, for the cautious and risky AIs. And as you can see, the humans actually degrade their performance when they're allowed to switch. We believe this is because there's an increased cognitive load with trying to complete the task and also handle the switching. So we note that the data somewhat resembles when the human is locked into the defender role. So we wondered if the humans actually preferred the defender role to the payload. So in order to look at this, we have 3 categories where the player chose not to switch during the switching experiments, playing as the payload for the entire session, where they switched before the gameplay began, which means they played as the defender the entire time, and when they switched during, at least once during the session. So here we have the ratio of all attempts that they played. The color of the bars depicts which AI they're collaborating with. Blue is cautious, purple is risky. And as you can see, the players chose not to switch and play as the payload about 30% of the time, regardless of which AI they were collaborating with. They chose to switch before and play as the defender about 60% of the time. And they chose to switch during only 5% of the time, roughly. So there's a clear preference for the defender role by the humans. But the humans, again, played over a long period of time. So does this performance form, we wondered if this preference forms quickly or if it evolves over time. So to look at this, we have the ratio of all attempts that the players controlled the defender. A value of 1 depicts full defender control, and a value of 0 depicts full payload control. And as you can see, this plot is a little messy. So for illustrative purposes, we group the players based on their trends. So here we have the mostly defender group. This group, over time or very quickly, decides that they want to play primarily as the defender. After session 7, they never controlled the defender less than 80% of the time. And we have the mostly payload group comprised of 2 humans. So even though they have a few spikes of high defender control, the vast majority of their data is at less than 50% defender control, so they mostly control the payload. And then we have the mixed group. This group didn't show a strong bias towards either the payload or the defender, but as you can see, towards the last third of the data, they seem to be trending towards defender control, thus showing a preference. So looking at this on aggregate, the humans just don't improve the performance, so why would we even look at this? Well, when we examine the humans individually, we see that several of them are able to outperform the AI on an individual basis. So this is an example where the human is playing as the defender, and they're able to collect all 6 sub-goals, thus outperforming the AI. And as you can see, they use a strategy where they put the defender in front of the payload and sort of sweep obstacles out of its path. And in this example, the human is controlling the payload. And rather than just rushing through the level, they choose to slow the payload down and let obstacles pass or allow the path ahead to become less crowded. And in this way, they also collect all 6 sub-goals. So in conclusion, we observe that the humans as a group prefer and perform better as the defender role. We believe that this is because the defender requires less active control than the payload does, and also that the defender role is more error tolerant than the payload role. We also observe that humans are unlikely to switch focus during gameplay, but we think this might change if we introduce multiple defenders into the scenario. And finally, we observe strategies where the humans are able to individually outperform the automation by facilitating it to work better. And by integrating the strategies seen into the automation in the future, we hope to observe more diverse player behavior. So thank you for listening to my talk. Any questions would be great.